And here we go with more of that redundancy stuff. And as always, we'll take as much of it as we can get. And now we're talking about router redundancy or first hop redundancy protocols, also sometimes referred to as FHRP if you spell out the word first. That's your acronym for the day. And if a router goes down, obviously, we have huge problems because hosts are relying on that router as a gateway to send packets to remote networks. And this is a major problem because it's a single point of failure. And that's a term we've used a couple of times here in the course, and we know it's a quick and or fancy way of saying if this thing goes down, we are in a lot of trouble. Our entire network comes to a standstill, and this router in this network is definitely a single point of failure. Well, router redundancy, it's not as difficult to get as you might think. And for true router redundancy, though, it's not enough just to have another router or to configure the load to leave two different ways, because if one of those ways breaks, you're still in a lot of trouble. So let's talk about what we need. We need, first off, that secondary router to handle the load immediately if the primary goes down. We also need a protocol to have the network use that secondary router quickly and transparently. Time, obviously, of the essence here. We need a protocol to first quickly detect the fact that the primary router is down. Then we need a fast cutover to the secondary router. Okay, sounds pretty easy so far. Here's the tricky part. We need this cutover to be transparent to the hosts. And that includes not moving them to a new default gateway. And that's what that scenario I mentioned a moment ago, where you say, okay, you got two routers and you got two exit points, and we'll point half of the end users at one router for their default gateway and the other half of the users at the other router for their default gateway. Well, what happens with the hosts if one of those routers goes down? Someone has got to go in there and change that default gateway. And no matter what method you use, it's not going to be fast enough. I can guarantee you that. So we need this cutover to be transparent to the hosts. How in the world are we going to pull that off? Stick around, you'll see. Now, if you go after your CCNP, and I hope you do, you'll actually see HSRP on the CCNP switch exam instead of the route exam. And that's because layer 3 switches have become so popular in today's networks that you'll find a lot of these router redundancy protocols actually being run in production networks on L3 switches. Now, it actually makes the cutover just a little bit faster when you have your FHRP on layer 3 because our end users are directly attached to those, and it's true first hop redundancy. Now, we have a couple of different methods, 3 that we're going to talk about in this section of the course actually, that allow us to achieve that goal of router redundancy. A very popular choice is HSRP, the Hot Standby Routing Protocol. Now, please note in this section, I'm going to refer to routers rather than L3 switches because the HSRP terminology itself does refer to active routers and standby routers. But the commands and the theory that you're going to see here, exactly the same for a layer 3 switch as they would be for a router. Let's talk about HSRP for a minute or two, and then we're actually going to go configure some. It's defined in RFC 2281 and is a Cisco proprietary protocol. And routers are put into a logical group, an HSRP group. One of the routers in the HSRP router group is going to be selected as the active router, and that router is the one that's actually performing the routing. The other routers in the group are in standby, and they're ready to handle the load and step in if the primary router becomes unavailable. Now, the terms active and standby that you are going to see throughout these discussions and throughout the lab, they don't have anything to do with the actual operational status of the routers, only to their status in the HSRP group. Now, here's the best part. The hosts don't know the actual IP or MAC addresses of the physical routers in the group. That's not where they're sending their data. They are sending their data to a pseudo router, a virtual router that's actually created by our HSRP configuration. This virtual router is going to have a MAC address. It's going to have an IP address just like a physical router. And as you might have guessed by now, the hosts are going to use the virtual router's IP address as a default gateway. That's the best part of HSRP, because if the physical router goes down, one of the routers in our group goes down, and another one steps in to take over the load, it's totally transparent to the host. They don't need to be reconfigured. They don't need to have their default gateway changed. Nobody's going to panic. and they're sending their packets continually to the IP address of the virtual router, not the physical one. And that's really HSRP in a nutshell. There are other features that you'll learn about in your NP studies, but this is the fundamental reason we use HSRP, and you're going to see it in action here in just a moment. Now, here's the network for our first lab, and here's what we're going to set up. And you can see that our hosts are going to be communicating actually with either router 2 or router 3, but we're going to have a virtual router in the mix as well. Routers 2 and 3 are at 172.12.23.2 and 3 respectively, and the virtual router will be at 172.12.23.10/24. We're not going to go into the config here on the board because I want you to see this on the live equipment. So on the very next video, we will start that with an HSRP lab. See you there.